All right, this will be our last video for our test 3 review. It says find all the zeros of f of x equals x cubed minus 6x squared plus 13x minus 10. Now, first of all, if you did the p's and q's, although it didn't say you had to, your p here is the factors of 10. So 1, 2, 5, and 10. And your factors of q, well, there's only going to be 1. And so the possible zeros are going to be 1, 2, 5, and 10, and also their negatives. So if you actually found the possible zeros, those would be it. I'm going to go ahead and erase this. I didn't ask you to actually find the possible zeros, but that's how you would do it. So you can go to your calculator now and find the first zero. If you haven't already done that, you should do that. There's a video that you should be able to have access to when you look at all my videos that shows you how to do this kind of thing on the calculator. All right, but anyway, you should get that 2 is a 0. So we got that off our calculator, and so now we're going to verify it's a 0. So go ahead and do synthetic division with 2. And so let's drop our 1, and 1 times 2 is 2. When we add, we get negative 4. Multiply, you get negative 8. When you add, you get 5. Multiply, you get 10. When you add, you get 0. So the bigger thing is we expected to get a remainder of 0 because we knew that 2 is a 0. But the bigger thing is this answer here is going to help us to break f of x down. All right, so f of x is going to be x minus 2, since 2 is a 0, times x squared minus 4x plus 5. Again, that comes from here. Remember, if this is x cubed, then this will be a 1x squared. The degree drops by 1. Now, you got to be really careful here. I've had many students do this problem, and they factor this trinomial, but it turns out it's not factorable. We need two numbers that multiply to 5 and add to negative 4. Now, there's no way you can get 1 times 5 is the only way to get 5. There's no way that you can get this combination to add up to a negative 4, no matter what you do. If you change the 5 to a negative, then your numbers won't multiply to 5 anymore. So anyway, it doesn't factor. So if it were me, I would use completing the square. It's probably the fastest way to do this problem. I'm going to go ahead and use the quadratic formula just because most people tend to go that route. But honestly, you can do it either way. So we can't factor. Let's go ahead and set this equal to 0. So our a is 1, our b is negative 4, and our c is 5. I'm going to write down the quadratic formula. And then I'm going to make a shell, and let's go ahead and put in the numbers. And so a is 1, I'm sorry, b is negative 4, a is 1, and c is 5. So this will be x equals a minus minus 4 becomes 4, plus or minus. Now inside the parentheses, we've got negative 4 squared, that's 16. Minus 4 times 1 times 5, that'll be minus 20. So you should get negative 4 there. And so this is the square root of negative 4, and that's over 2. Now let's break this into two fractions. This will become 4 over 2, plus or minus. Now remember, if you have a negative under the square root, you're going to be pulling out an I. The square root of negative 4 is 2i, and that's over 2. And so we're going to end up with 2 plus I. And so our zeros are going to be 2, 2 plus I, and 2 minus I. All right, let's look at number 16. It says find the domain. Now remember, when we're dealing with fractions, our denominator cannot be 0 because then we would be undefined. Basically, the domain includes all the x values that we can plug into this function, and our output's going to be a real number. Well, if we plug in an input and it causes our denominator to be 0, we're undefined. And so that would be the only exception with rational functions. So in this case, it's a little harder to tell just by looking at the denominator what x can't be. The easiest way to do it is just set this equal to 0. 3x plus 2 equals 0. And let's go ahead and solve that. We'll get 3x equals negative 2. Divide by 3, you get x equals negative 2/3. And so this is our restricted value. X cannot equal negative 2/3. And so our domain is basically every other real number. So negative infinity up to negative 2/3. And then notice we're putting a parenthesis because we're not including negative 2/3. And then we're going to union that with negative 2/3 to infinity. And so that's how we would basically say we can plug in any x value into this function except negative 2/3. Our domain is everything except negative 2/3. All right, on number 17, you're finding vertical, horizontal, and oblique asymptotes. So on A, notice our denominator is a trinomial. It looks like we could factor this using the AC method. I'm just going to go ahead and do that. I expect everybody can factor that by now. You get x minus 6 times x plus 4. So you can see that our denominator would be 0 if x were 6 or negative 4. Those are our restricted values. Those are the values that if you plug them into the function, it makes the function undefined. So we can plug in any other numbers except those. Now we learned that our vertical asymptotes occur at our restricted values. And so that's just going to be x equals 6 and x equals negative 4. So whatever your restricted values are, those are going to tell you where your vertical asymptotes are going to be on the graph. Now, for finding horizontal asymptotes, remember there were 3 cases. If you don't remember the 3 cases, you may want to go back to section 4.5 and look at that. So in this case, the degree of the denominator is greater. I call it bottom heavy, and in that case, your horizontal asymptote is going to be y equals 0. Now, the only time you would have an oblique asymptote, so that's the bottom heavy case, the only time that you would have an oblique asymptote is when your numerator has the bigger degree, or your top heavy, and so in this case we won't have an oblique asymptote. All right, so on letter B here, notice x can't be 1. Excuse me, that's my restricted value, and so that's where I'll have a vertical asymptote. In this case, we're top heavy, or the degree in the numerator is bigger than the degree in the denominator. So this is the case where there is no horizontal asymptote, and in fact, this is the case where we have an oblique asymptote. To find the oblique asymptote, we're going to have to divide here. Now in this case, since we're dividing by a linear function, and there's a 1x here, we can use synthetic division. So I'm going to use again, this was top heavy, that's why we didn't have a horizontal asymptote. So let's do the synthetic division. So we're dividing by x minus 1, so we're going to put 1 in the box. And so I've gone ahead and set this up, so let's drop the 2, and 2 times 1 is 2. When we add, we get 3. 3 times 1 is 3. When we add, we get 2. And so our answer here, when we do this division, is 2x plus 3 plus 2 over x minus 1. So basically all we did is divide this, and this was our answer. So really we have another way to write g of x. We could say g of x is equal to 2x plus 3 plus 2 over x minus 1. Our asymptote comes from this part right here. It's y equals 2x plus 3. Now, just briefly, I'll try to explain why. Basically, remember that horizontal asymptotes and also oblique asymptotes mainly tell us about what's going on the ends as x gets really big or small. So in this function g, if x were really big, say 1,000, and as x gets bigger and bigger, this would be 2 over 1,000 minus 1. 2 over a really big number, that's going to get closer and closer to 0. So as x gets really big, this graph is going to get closer and closer to y equals 2x plus 3 because this part goes to 0. So that's the basic idea. And the same is true when x gets really big negative. All right, let's move on to the next problem. So here we have f of x equals 3 over x plus 4. So first of all, our x can't be negative 4. That's our restricted value. And of course, we know that's where we're going to have a vertical asymptote. Since this one is bottom heavy, the degree is bigger in the denominator, we know we have a horizontal asymptote at y equals 0. There's not going to be an oblique asymptote. Remember, you're only going to have an oblique asymptote when you're top heavy or the numerator has the bigger degree. Next, we need to find a few points. So the easiest to find are usually intercepts, or at least certainly the y-intercept's pretty easy to find. So let's find f of 0. So we get 3 over 0 plus 4, which is 3/4. So 0 3/4 is your y-intercept. To find the x-intercept, we're going to let y be 0. Remember, f of x is just another name for y. And so we're going to get 0 equals 3 over x plus 4. Now you could multiply both sides by x plus 4 and you end up with 0 equals 3, which means there's no solution because you get a false statement. However, remember that a fraction can only equal 0 if the numerator is 0. Well, since the numerator has a 3 in it and there's no variable, we're going to never have a numerator of 0. So really all we have to do is set our numerator equal to 0, and if there's no solution there, then we don't have an x-intercept, which is the case here. All right, so now let's go ahead and put in our asymptotes. And let's put in our one point that we found, 0 3/4. So you can see we need to find a few more points to get an idea of what this graph's going to look like. Now we know with situations like this, on the ends we tend to have arcs. And so let's go ahead and we need to find a couple of points. I've got that one point at 0 3/4. It'd be nice to maybe have -1, -2, or -3. I'm going to choose -3. And then over here it'd be nice maybe to know, because we need to know what's going on this side of the, I hit the wrong button here. Oh goodness, let me go back here. Sorry about this. I hit a bad button. Just give me a minute here. We'll get to all that. All right, so we're basically looking over here, and we need to find a couple points over there. I don't know if my graph's going to be up here or down here, and so let's choose -6 and -5, and then maybe -3 on the other side. And so I'm going to go ahead and do this by hand. Now you should be able to do these by hand, but you should also be able to do them on a calculator. On a test, you probably want to use your calculator to help you to save some time. But you'll find that it's important to be able to do this kind of thing by hand as well, especially when you move on to a higher level math course. You should certainly be able to plug in values into a function. So if I plug in -6, that's going to be 3 over -6 plus 4, which is 3 over -2 or -1.5. If I plug in -5, you get -3. If you plug in -3, let's say you have 3 over -3 plus 4, that's 3 over 1, which is 3. And so now let's go ahead and let's see, put in these points. So -6, -1.5, and -5, -3. Notice those 2 points there. So that really gives me all I need to know to draw the graph, I know that this graph is going to approach the horizontal asymptote on the ends. So as you go to the left here, it's going to look like that. And then going to the right, remember we can't cross a horizontal asymptote, a vertical asymptote. So we have nowhere to go but closer and closer to this vertical asymptote. And then on the other side, we have negative 3, 3. So you can see, again, going to the right as we're going to approach the horizontal or the vertical asymptote. No, I said that wrong. The horizontal asymptote. And then as you go back to the left, again, you can't cross that vertical asymptote. And so it's going to look like that. All right, so let's go ahead and move on to the next problem. Now, in a problem like this, look at our numerator and denominator. I'm thinking I'm going to want to graph this, or not graph it, but factor so that if there's common factors, I can simplify. So it's always a good idea to factor in a situation like this first. So let's go ahead and do that. You can write this as f of x is equal to x minus 2 times x plus 1 over x minus 6 times x plus 1. So now I can see, excuse me, what my restricted values are. That would be 6 and negative 1. But notice also we have before I get into that, the domain. Let's talk about the domain. Let me go back here. So our domain can't include negative 1 or 6, so we're going to go from negative infinity to negative 1, and then we go to 6, so from 1 to 6, negative 1 to 6, and then from 6 to infinity. So basically this means our domain is all real numbers except negative 1 and 6. That's why we use the parentheses by the negative 1 and the 6. We're excluding those two values. Everything else is okay as far as the domain's concerned. Now let's go ahead and cancel those x plus 1s. And you're going to get f of x equals x minus 2 over x minus 6. Notice x cannot be 6 here when we graph this function. And so that's where we're going to have our vertical asymptote. I just want to mention, so at x equals 6, that's where we're going to have our vertical asymptote. Wherever we have a common factor that gets crossed out, in this case x plus 1, that's where we're going to have a hole. So we're basically graphing this function here. But when we do so, we need to make sure that we don't have a point where x equals negative 1. Because the original function, if we plug in negative 1, we would be undefined. All right, so let's go ahead and continue here. So our vertical asymptote will be at x equals 6, our restricted value. Again, right now we're basically graphing this part right here. Our horizontal asymptotes, notice the degree of the numerator and denominator is the same. This is what I call the balanced case. And we're going to use the coefficients of the leading terms. So that would be 1x and 1x, so y equals 1 over 1, which means y is going to equal 1. And this is the balance case, so we won't have an oblique asymptote. Next, we need to find intercepts. So for the y-intercept, we'll find f of 0. So it'll be 0 minus 2 over 0 minus 6. And you're going to end up with 1/3. So 0, 1/3. Let me go ahead and do the x-intercepts down here. Let's see if we have any. So we want to let y be 0. And so we have 0 equals x minus 2 over x minus 6. Now again, this fraction can only equal 0 if the numerator equals 0. So set your numerator equal to 0, and you get x equals 2. So the x-intercept is 2, 0. All right, so let's go ahead and put in our vertical and horizontal asymptotes, and also our points, 0, 1/3, and 2, 0. Now it looks like we've got things figured out here. I'm guessing it's going to look something like this. Just to double check, maybe I'll find out what happens when I plug 5 into the function. And then also you can see 7 and 8 would be good values so that we know what's happening on this other side of the vertical asymptote. So I would like to find these 3 points, and I'm going to use the calculator here, and you should get -3, 5, and 3. So I'm going to go ahead and put in the point 5, -3, and so I got the kind of arc I was expecting there. It's going to look like that. And then on the right side of the vertical asymptote, let's put in our 2 points, 7, 5, and 8, 3. And you can see that, well, first of all, the graph will be up in this region here, and so our arc is going to look something like that. Now don't forget, we're going to have a hole, remember, at -1. And so let's go ahead and put that in. And so there's your graph. So basically, this graph for this function is just like the graph of f of x equals x minus 2 over x minus 6. The only difference is there's a hole at x equals -1. All right, let's move on to the last problem. So on number 20, I would encourage you to read this. I'm just going to do it to save some time here. It says, what is the concentration of the drug in the bloodstream after 6 hours? Well, 6 hours, T is 6 here. T stands for time. The concentration is what they're calling C of T. And so basically what they're asking us to find here is C of 6. So when you plug 6 into the function, notice our numerator, you're going to get 120. In the denominator, you have 6 squared plus 4. Well, that's 36 plus 4, that's 40. And we get 3. Now, you can use your calculator to do this. This one was actually pretty easy to do by hand. And so we got C of 6 equals 3. Now, remember, this is C of 6. C stands for the concentration, and notice that's in milligrams per liter, and so it's 3 milligrams per liter. Now remember, a 2-liter bottle of Pepsi, you kind of got a picture of what that looks like. A liter would be half of that, 1 liter. So there's basically 3 milligrams of the drug in the bloodstream, basically per liter after 6 hours. All right, let's move on to B. It says find the horizontal asymptote and explain what it means in the context of this problem. Well, this one's bottom heavy. The degree in the denominator is bigger, and so y equals 0 is going to be your horizontal asymptote. So what does that mean? So go ahead and read the problem again and see if you can answer that question, and then I'll put up the answer here. All right, so you should have said, as time passes, the amount of the drug in the bloodstream will approach 0. Or you could have said the amount of the drug is going to approach 0 as the time passes, or something along those lines. Another way to say this is, as t approaches infinity, or as the time gets greater, the amount of the concentration of the drug in the bloodstream is going to approach 0. C of t will approach 0. All right, so that's the end of this video.